All right, for this video, we're going to do a brief introduction on the whole purpose of inverse trig functions. And when I say inverse trig functions, what I mean is if I just skip down to this, we've actually have done these problems before, where really most of these problems you get two answers, but on the calculator we only get one answer. And we're going to explain why we only get one answer on the calculator, and it has to do with this, the vertical line test. But another way of looking at this one where it says cosine of theta equals negative root 2 over 2, that's, if you're finding the angle, you're really doing the inverse cosine of negative root 2 over 2. All right. Now, if I actually did that, when we did it before on a quiz probably about a month ago, these are the two angles that you would get, 3 pi over 4 and 5 pi over 4, because the x value is negative root 2 over 2. But on the calculator, when you put this in the calculator, it only gives you 3 pi over 4 as the answer. All right. And the reason is I'm going to get to this vertical line test. This 3 pi over 4, if we were to graph, and we're going to do it on the next page, if we were to graph the inverse of cosine, this 3 pi over 4 is going to be in a region that passes the vertical line test. 5 pi over 4, when we graph the inverse, it's going to be in a region where it fails the vertical line test. All right. Now remember, vertical line test, it's stated there. It's when a graph is a function if no vertical line passes through more than one point. All right. So in order to get the graph of the inverse, let's just get the normal cosine graph. So let's go to the next page. All right, let's see here. Whoops, I'm going to move this up. Okay, so on this first part right here, you see I already have it filled out. We already know how to graph sine and cosine. We've done all the trig functions. Cosine starts at the max. So it starts here. Let's say this is 0, 1. Then it goes to the equilibrium. Say this is negative 1. It goes to the minimum, then to the equilibrium, and then at the max. So this is just one period that we graphed. Now I know if I graph the whole thing, it just goes forever in both directions. All right. Now it says, does this pass the vertical line test? Yes, it does. Definitely passes the vertical line test. But what's going to happen is when we graph its inverse, the biggest feature when you graph an inverse function is, remember, you switch the x and the y chart. And what you'll see is going to happen is, instead of having a wave that goes left to right, you're going to have, it's going to look something like this. It's going to be a wave that goes up and down because you're going to switch the x and the y. Okay, and to prove it, now this fails the vertical line test, right? It goes through many different points right here. All right, so to kind of prove that, let's move down. And you can see I already switched the x and the y values right here. Right, I already switched them. So this is my inverse. Now I put the decimals in for like pi over 2 and pi, 3 pi over 2 is 4.7, 2 pi 6.28. All right, so let's graph this. So 1, 0 is right here. The next point we have 0, 1.5. So this is 1, 2. It's about right there. Again, it's going to be a little sloppy. Then we have negative 1, 3.14. So it's here 1, 2, 3, 4. So negative 1, 3.14 is right about there. Then we have 0, 4.7. 0, 1, 2, 3, 4. 0, 4.7 is like right about here. And then 1, 2 pi, which is 1, 6.28. 6, 7. So 1, 6.28, 1, 2, 3, 4, 5. And it's like right about here. And look, when you connect it, it proves that you get this wave now goes up and down. So even when I just graphed one period of that inverse cosine, this fails the vertical line test. So this is a big no right there. Now, if you were to actually graph this on your TI Inspire, when you graph anything on your TI Inspire, it has to pass the vertical line test. It has to be a function. It can only graph functions. So if you were actually to graph this, I'll put this in a different color, you actually only get this little arc. Because as soon as I go past this arc, as soon as I hit, like, this is kind of like the max, as soon as I turn, then it fails the vertical line test. And here's the main point right here. If you look, the y value here is 0. And right at this point, that's the last point where it passes the vertical line test. This y value is this right here. It's pi. All right, that's where it passes the vertical line test. So when I move down, okay, I said if it does not, which it doesn't, where does the graph pass the vertical line test? It's between, it's between these two values. So for inverse cosine, on the calculator, if you put in inverse cosine, it will only give you answers between 0 and pi. So that's why when I did that problem on the first side, it gave me 3 pi over 4 as an answer, because that's in between 0 and pi. 5 pi over 4, it won't give you that as the answer, because 5 pi over 4, that would be on the graph where it fails the vertical line test. Okay? So in the end, the problems, you're going to see the next couple videos are going to be real simple. You just go back to the unit circle, but instead of getting 2 answers, you're only going to get 1 answer. Now, I only did inverse cosine, but if we were to do the same exact thing, if I were to graph inverse sine, this would pass the vertical line test in only the 4th quadrant and the 1st quadrant, but it makes the 4th quadrant negative. It goes negative pi over 2 to pi over 2. Same thing for inverse tangent. All right, and you're going to see it also says arc cosine, arc sine, and arc tangent. That's the same thing as using this terminology. So we're going to go back to problems that we did before, but now you're only going to get what's called the principal value. You're only going to get 1 answer. You're not going to get 2.